Thank you very much for inviting me to this excellent conference. I've looked forward to it for days since I've been invited, and it's turning out to be everything I hoped for. As the slide says, my name is Marc Stanton. I'm the Commercial Director of Smart Power Solutions. Now, Smart Power is a new company, and it's been formed by the amalgamation of Clean Power Solutions and Smart Homes, both of whom worked in different aspects of renewable energy, and we came together for hydrogen. And I'm very proud to say Smart Power is actually a Scottish company. We're based at Methyll, and we work very closely with the Scottish Fuel Cell Hydrogen Association at their offices there in Fife. Now, we've developed a smart synthetic grid system that can absorb reactive power, balance phasors, control voltage risers, and turn the excess power that's not needed by demand into green hydrogen. And this can be used either as vehicle fuel or as heating fuel. And next week we're hoping the system will also be able to make cups of tea and do a bit of cleaning. Now, we originally became interested in hydrogen when we had 25 orders for wind turbines, small wind turbines, 20 kilowatt ones, on Westray, on Orkney. And the local DNO, God bless them, Scottish Hydro, they changed the rules. And all of a sudden, all installations had to be at G83, that's 16 amps per phase, at the inverter. Now, at first, we didn't think that was really a problem. We didn't really understand quite what they meant. And as we were agents for Emma, we thought, okay, that's not a problem. We can use the Emma device, and that will solve all the problems. And for those of you that don't know the Emma device, it's a very clever series of SSRs and CTs that divert the available power to various other uses, such as thermal stores, etc., or it can go to cooling or hot water or whatever it wants. And it instantly matches supply to demand and can restrict export to a predetermined level. The problem was, of course, what to do with all the power. We couldn't send it all to a dump load. I am aware that actually in Orkney there is a company that is doing that, which is a bit naughty, but I won't mention it. But you had to have a use for the power. As I said, we couldn't send it all to a dump load. We could see the headlines in the newspapers. You know, every Scots costs every homeowner in England £3,000 a year to heat the back garden. We therefore had to have a use for all of the power before it arrived at the inverter. Not only would this require a smart synthetic grid, battery storage system that could supply the site as an off-grid solution while still being connected to the grid, but also we had to find a realistic use for the energy. Now, this required copious quantities of a substance that makes my brain work far better than usual, and some of you from last night will be aware of this, and several pub landlords had very nice holidays because of our thinking sessions. We thought about everything. We thought of having trailers with battery banks to deliver a week's worth of electricity to your neighbour, and that wasn't going to work. Electricity isn't that expensive. We thought of pumping water over a fence to create a small hydro system. That wasn't going to work either. It would have worked, but it just wasn't going to be viable. We thought of everything, and eventually one of our thoughts was hydrogen. The problem was that the only production systems were either huge, big ITM-type systems or small laboratory-sized production methods that putted out a little bit of hydrogen. And then we found the Actor-Spar electrolyser, which was specifically designed to work with renewable energy and could handle varying amounts of power input because of the nature of renewable energy. If we just gave it a kilowatt, it breathed some hydrogen. If we pumped lots of power into it, it pumped out lots of hydrogen. And this would work brilliantly as a sink for the excess power that was not required by the smart grid, and it would match supply with demand to balance the system. So we now had a production method, but what to do with the hydrogen? We then found the Giacomini central heating boiler, which is the only catalytic central heating boiler that works on hydrogen. And when we did the sums for a 20 kilowatt wind turbine, the electricity usage for a 4-bedroom house with an Actor-Spar electrolyser and a Giacomini boiler, it all balanced, which we thought was brilliant. But then we went further and we thought, what if? What if we produced more hydrogen? What if we could compress it and use it as a vehicle fuel? Well, we'd suddenly seen the light. The period between now and 2020 will be the most crucially important for the field of smart grids, but also for the creation of a hydrogen infrastructure and the promotion of the hydrogen vehicle industry. We are faced with a proverbial chicken and egg situation. No one wants to be the first person to own a telephone or the first person to own a hydrogen-powered vehicle. Who are you going to call, and where are you going to go? There is, however, a viable business opportunity in the UK and the rest of the world for mobile refuelling stations or facilities, and this will help create local clusters of smart grid, synthetic grid facilities, which will have the concomitant effect on the popularity of hydrogen-powered vehicles, whilst enabling smart grid technology to develop with its concomitant effects on peak demand, etc. In addition, uptake of our system for specific strategic reasons will enable the operator to open to the public and reduce their own costs by creating an income stream from the sale of hydrogen. And this will also have the benefit of not reducing the load on the local network, but actually increasing it, which for many areas, especially Scotland, is vitally important. So then we realised the enormity of what we'd stumbled across. Not only had we found a solution to our problem, we'd also discovered a solution to a lot of other people's problems. Creating a hydrogen infrastructure was one of them. We'd created a solution for not only excess but redundant energy. We discovered a smart grid solution to the problem of storing renewable energy, solving problems of reactive power and voltage stabilisation within the grid, whilst creating battery storage for the use of the power on site. And this in turn had started to create a small but significant infrastructure of refuelling stations that could be used before the main national infrastructure became self-sustaining. As a retrofit to any renewable energy producer that already has a grid connection, certainly a G59 connection, and unlimited export facilities, then there's no point at all in installing the system, unless there are strategic reasons for the implementation, such as the need to create a smart grid. However, if you're not allowed to export all of the power that you could produce, or if you're not allowed to export to the grid for reasons of location or export availability, then this offers not only an economic smart grid solution, but also a unique income stream and a solution to the local network. Refuelling stations can be installed, or satellite refuelling stations can be supplied with green fuel produced as a byproduct of power generation and the use of a smart synthetic grid. A further consideration has to be made of the additional solutions that this system offers, not just to the installer, but also the grid operator. The problem of renewable energy being allowed into the national grid is not just here in the UK, but also worldwide. Reactive power and voltage fluctuations are a serious concern to all grid operators. This system not only restricts more power into the grid, but the very action of being connected to the grid calms down the local network. And hopefully it means it will encourage take-up by the grid operators. The concomitant of this, of course, is the increased uptake of hydrogen production across the UK, EU and worldwide. Now, as we're all aware, hydrogen is a strange beastie. It's not like other hydrogen-based fuels. Driving a 25,000 litre tanker once a week to the petrol station is not really going to be financially viable or even possible, except in a few locations. Pipelines could be an answer, but not really. The problem with hydrogen, it can seep through 4 inches of stainless steel. If you put it under pressure, you can imagine the problems with building a pipeline. So what is needed is the ability to produce fuel either at site or in the near location, where resupply could be done once or twice or even thrice daily. Now, can anyone here think of a location that have large areas of open space that are frequented 24 hours a day and have a requirement for fuel? I can. Supermarkets. They all have large roofs and car parks. They could easily be covered with solar panels and power stored in a smart synthetic grid. The area over the car park would offer undercover loading for customers. Some of the power could be given away as free electric vehicle charging points, and the excess stored in smart synthetic grid converted into hydrogen and used to power their delivery vans with "this vehicle is powered by hydrogen" written across it. It also means that the supermarkets or other industries, distribution depots, warehouses, factories, anywhere such as that, could have a hydrogen refuelling facility on site and available to be installed either at their on-site petrol station, or they could open to the public. In addition, energy costs would be reduced, the local network would be calmed down, and peak demand would be avoided. Same thing goes for motorway service stations, or as I've said, other factories or distribution areas. In Swindon, the Honda project with Briggs Equipment are investigating the possibility of using solar power created hydrogen as the main fuel for the fleet of forklift trucks. And developed with help of Honda at their Swindon factory, they are converting Yale forklift trucks to have small lithium-ion batteries that are fed by a hydrogen-powered fuel cell that keeps the battery constantly topped up. This means that maintenance is drastically reduced, refueling time slashed, as battery banks do not need to be removed and charged, just a tank filled. The eventual idea is that factories all over the country could create their own fuel for forklift trucks and make excess fuel available to the public at public fuel stations. Swindon Council already have a small fleet of hydrogen vans, and we are talking to several councils here in Scotland about doing the same thing with their own council vehicles. The smart power system allows integration of renewable energy sources via standard, normally grid-tied inverters to a smart grid without the physical tie to the mains grid by creating a synthetic grid from the stored battery energy. The system incorporates facilities to provide syncing and sourcing of reactive power and voltage risers that are often associated with renewable energy sourced to enable delivery of a stable supply. Hydrogen is extracted from rainwater using only surplus renewable energy, sourced after the site demand is satisfied and the battery store is charged to a set point. And this means that the hydrogen that we do produce is produced to a purity of 99.997%. It's also completely pure, and it's also, of course, green. The whole production system and smart grid can be containerized in a 40-foot container or put on skids and delivered anywhere in the world with a plug-in system. The cost it depends on what you want, how much power you're going to give us, how much you need and how long, etc. Circa £320,000. But if you amortise this over 20 years, with the number of vehicles you can run, it means you can run your fleet for about £3 a day. And presuming you work 5 days a week, that price is locked in for the next 20 years. At the moment, you can spend that on a cup of coffee. In 10 years' time, it won't buy you the paper cup. Local communities are often those that suffer from isolation and fuel poverty the most. The very fact of their isolation not only creates problems of delivery and availability of both heating and vehicle fuel, but also the concomitant problem of increased cost. The chap at the back was talking already about how much more expensive it is if you're in the Highlands. This system with a smart grid not only offers the opportunity for communities to work together to create an infrastructure of refueling stations, but to create a unified, coherent and cohesive solution that can help ameliorate many of the problems, whilst attracting grant funding and creating an income stream for the benefit of the community as a whole. A benefit that will outlast many of the residents and presumably become a societal heirloom. A community could install renewable energy, such as wind turbines or solar PV panels, to supply themselves with cheap, if not free, electricity and convert the excess to hydrogen. This could be used as vehicle fuel in their farm vehicles, personal cars or even fishing boats. An additional income could be supplied to the community by selling fuel to passing motorists or offering refueling facilities to the local ferry or other requirements. In several of the areas here in Scotland, hydrogen is already being contemplated as a fuel for ferries and for other vehicles as well. And this system offers the opportunity to not only reduce fuel poverty, but help establish an infrastructure to find the answer to the eternal question of which comes first. Thank you for listening. If anyone wants to see me afterwards, please do come and see me. We're extremely interested in working with other people and finding other solutions to everyone else's problem. So thank you.